Good morning. My name is Mykhailo Derkach. I am a student of Junior Academy of Sciences of Ukraine. The theme of my presentation is large torsional deformation of straight prism with equilateral semi-regular polygon in the basis. Polyhedra of different types are used in architecture, art, and in various fields of sciences and technologies. In recent years, twisted anti-prisms, the geometry properties of which have been little studied, are widely used for modeling in physics, chemistry, crystallography, biology, and architecture. During the work, we use different geometric objects. Here are their definitions. First, an equilateral semi-regular polygon. Imagine that we have a square and add isosceles triangles to its sides. Then the polygon will have equal side and its angles will be equal through 1. So, an equilateral semi-regular polygon is a polygon whose all sides are equal and whose angles are equal through 1. Next, a twisted antiprism is a convex or non-convex prismatoid with triangular side faces and equal semi-regular polygon in the bases, and the center of the polygon at the top base is projected into the center of the lower base. Now we build a physical model of the torsional deformation of a straight prism. To do this, let's make some assumptions. First, the deformation of the prisms is a result of rotation of the polygon of the upper base at some angle around its center. Second, each lateral face of the prism is broken down along one of the diagonals of the initial rectangle. The project considers various models for a twisted antiprism. Mathematical model with a constant height h, mathematical model with a constant length d of the antiprism edges, which was the diagonals of the face of a straight prism, and mathematical model of prism deformation with a constant lateral edges b, that possible only for the right prism. During the work, we investigated changing the position of the end of the side h of the initial correct prism. So, for right prism, if the length of the lateral edge b is fixed, and the length of the lateral edge is equal to the diameter of the circle described around the base, when the upper base is turned, the end of the lateral edge is displaced along the Viennese curve. Also, for lateral edges that equal the diameter of the circle described around the base, the projection of the lane along which the end of the constant side edge of a correct prism moves during its torsional deformations onto the plane that touches the cylinder along a straight line containing the original edge of the prism is a Guido Grandi rose. We also proved that the cotangent of the angle between the side h and the base for the model with a constant height satisfies the equation of Guido Grandi roses. And for the model with a constant length of the side h, the cotangent satisfies the equation of deformed Guido Grandi rose. We also investigated the cotangent of the angle between the diagonal and the base. Therefore, during the work, we investigated the characteristics of twisted antiprisms that occur during large torsional deformation. Thank you for your attention.